I need to tell you exactly what happened at 3:47 a.m. today, because that moment marked a turning point not just in the study of 3I Atlas, but in our understanding of what may be unfolding inside our own solar system. While most of the world slept, NASA quietly pushed a new, unannounced data package to one of its restricted deep space servers. No press release, no scheduled briefing, just a silent digital footprint at the edge of a directory that only a handful of researchers monitor daily. And the moment I opened it, I knew something was different. Inside the package were high-resolution, multi-spectrum images of 3I Atlas far sharper than anything previously released. These weren't the distant, grainy captures we've been forced to interpret for weeks. These frames came directly from upgraded radar arrays, long-range optical telescopes, deep space tracking antennas, and thermal imaging systems capable of isolating tiny temperature shifts across rotating bodies millions of kilometers away. Individually, each instrument reveals part of the story. Combined, they expose something far more unsettling. At 4:02 a.m., I forwarded the files to colleagues in Europe. By 4:19 a.m., another group in Asia was already cross-analyzing the wavelength overlays. Within 90 minutes, 5 separate teams experts in radar interferometry, spectral analysis, astrophysics, and planetary geology were reviewing the same dataset. And despite our differences in background, methodology, and internal skepticism, our conclusions converged disturbingly fast. These new images don't simply refine what we knew, they contradict it. What we're seeing in this footage isn't a static interstellar object traveling along a predictable path. It's not a strange but natural comet shedding material as it swings around the sundial. Instead, 3I Atlas appears to be changing, not through erosion or fragmentation, but through reorganization. Entire regions of the surface look rearranged compared to earlier observations. Shapes that were once chaotic now seem structured. Patterns that were barely visible before now appear deliberate, aligned, almost coordinated. And then there's the moment that made all of us stop. In the final sequence, the last 12 frames recorded just hours before the upload, a faint geometric progression emerges across the object's illuminated side. It's subtle but consistent. A repeating pulse of light and shadow that doesn't match rotation, doesn't match thermal variance, and doesn't match any natural scattering model. When tracked across multiple wavelengths, the pattern holds its structure, it aligns, it repeats, it behaves. For months, the official stance has been reassuring. Yes, it's unusual, but still natural. That phrase has been repeated endlessly, protecting the public narrative and insulating scientific institutions from speculation. But this new footage doesn't fit inside that narrative anymore. It pushes against it, breaks it, burns straight through it. Because once you isolate the pattern, once you follow its rhythm frame by frame, a terrifying possibility becomes impossible to ignore. 3I Atlas isn't just passing through the solar system. Something is happening to it, or something inside it is waking up. Before we go any deeper into the new footage, we need to reset the foundation, because understanding what 3I Atlas is supposed to be is the only way to grasp how far these new images break from every expectation. Officially, 3I Atlas is categorized as the third interstellar object ever detected by humanity. Not an asteroid from our solar system, not a comet from the Kuiper Belt. This thing came from elsewhere, from deep space beyond the sun's gravitational reach, entering our cosmic neighborhood on a hyperbolic path that marks it unmistakably as an outsider. The two that came before it, Oumuamua and Borisov, already challenged astronomers, but 3I Atlas stood out immediately. It moved differently, reflected light differently, behaved in ways no simple ice and dust visitor should. Still, the safest story, the one repeated in interviews, press conferences, and official statements, was simple. Unusual, yes, but natural. That phrase became the shield, a way to reassure both the scientific community and the public that nothing extraordinary was happening. After all, space is filled with strange chemistry, extreme temperatures, violent radiation, and physics we only partially understand. Labeling something exotic but natural is a reliable way to close uncomfortable conversations. The early images helped maintain that illusion. Long-distance captures showed a lumpy, elongated body, not unlike Oumuamua, though with sharper edges and oddly geometric regions that many dismissed as coincidence or noise. Some researchers noted repeating surface patterns, but without clarity, those hints dissolved into speculation. The narrative remained stable, a rare visitor, here briefly, leaving soon, demanding curiosity, not concern. And its trajectory supported that idea. Hyperbolic paths do not loop. They do not circle back. They do not stay. Objects like this dive in, swing around the sun, and then disappear forever into interstellar night. A brief encounter, a cosmic passerby. No threat, no mystery beyond. We've never seen one quite like this. But even in those early days, cracks were forming. The light curve data didn't match expected tumbling behavior. Some wavelengths reflected too smoothly, others fluctuated too sharply. Its rotation seemed inconsistent, and beneath every attempt to categorize it neatly, there was a growing sense whispered at conferences, buried in footnotes, debated in private channels, that 3I Atlas might not follow the same rules as its predecessors. Still, the official stance held firm. Nothing to worry about, just an uncommon rock on a one-way trip. But that was before this week. Before the new multispectrum imagery, before the structural features sharpened, before the surface changes became impossible to dismiss as noise, before the patterns repeated too precisely, too consistently, too intentionally to ignore. The truth is simple. To understand why the new footage is so alarming, you need to understand the comforting framework we've all been relying on, the idea that 3I Atlas is a predictable, passive traveler from another star. Because what NASA's latest images show doesn't line up with that story anymore. Not even close. And if the foundation collapses, so does everything built on top of it. Which brings us to the footage itself and the moment the data stopped behaving like nature and started behaving like something else entirely. Now we reach the point where the story stops being strange and starts becoming deeply unsettling, because the newest NASA footage doesn't just improve our view of 3I Atlas, it redefines it. These aren't marginal upgrades or slightly sharper frames. What NASA uploaded is a leap in clarity so dramatic that it forces every previous interpretation back onto the table. The first thing that shocked all of us was the resolution. Earlier observations came from distant optical snapshots, occasional radar reflections, and the kind of data you expect when tracking a fast-moving visitor tens of millions of kilometers away. Enough to form hypotheses, but not enough to confirm anything bold. The new images, however, come from a coordinated multi-instrument campaign involving deep space antennas, high-energy radar sweeps, and long-exposure optical channels. The result is a level of detail no one believed we'd get until a probe physically flew past the object. To put it simply, we can now see features on the surface of 3I Atlas that are comparable in scale to major landmarks on Earth: ridges, depressions, repetitive structures, and reflective zones that stand out in ways previous data only hinted at. If the older images gave us a rough silhouette, these new ones offer something that looks disturbingly close to a technical blueprint. And that's what set off alarm bells. As the data came in, the first frames looked familiar enough: the elongated body, the irregular patches, the scattered shadows. But within seconds, as the wavelength layers stacked together, we all saw it. The surface doesn't match the surface we saw in the October captures. Entire regions appear reorganized. Patterns we assumed were noise have become symmetrical. Shapes that once looked like random fractures now align with geometric precision, as though obeying rules instead of nature's usual chaos. Every wavelength told the same story. Optical, sharp edges where none existed before. Radar, clean. Repeated returns, impossible for a rough rotating rock. Thermal, temperature gradients too organized to be random. Filtered hyperspectrum, subtle surface signatures matching metals, composites, and compounds we don't see on typical comets or asteroids or anything naturally drifting through space. Scientists rarely agree quickly, especially across different disciplines. Yet the messages I received within minutes of the upload all echoed the same sentiment. This isn't behaving like a natural object. But then came the detail we can't unsee. In the final segment of the footage, less than a dozen high-resolution frames, a faint sequence of alternating reflectivity, appears along one of the object's flanks. At first glance, it looks like nothing, but when tracked over time across both thermal and radar overlays, the pattern holds its timing with uncanny consistency. It pulses, not as a flare, not as a heat spike, not as a rotational artifact, but as a repeatable, synchronized signal emerging from the same region again and again. Signals in nature do occur, but not like this. Not with timing, not with regular spacing, not with cross-spectrum coherence. Not with persistence across multiple instruments, positioned thousands of kilometers apart. Whatever is happening on 3I Atlas, it's not noise, it's not glitch, and it's not chance. These new images don't just expand our knowledge, they challenge the fundamental assumption that we are observing an inert visitor. Because once the patterns sync visually, thermally, and in radar returns, the simplest explanation is also the most horrifying. Something on the surface of 3I Atlas is active. And the resolution is now high enough that the object's behavior can no longer be brushed aside as natural variation. Which leads us to the next question, a question no one wanted to face. If the surface is changing, if the patterns are repeating, if the signals are coordinating, what exactly is 3I Atlas turning into? The most jarring discovery in the new footage isn't just what 3I Atlas looks like, it's how fast it's changing. Interstellar objects simply do not behave this way. Once they enter our solar system, the physics is predictable. Sublimation, erosion, fragmentation, rotation, drift. They lose material. They don't gain it. They fracture. They don't reorganize. They dim. They don't pulse. But 3I Atlas is doing all of the things it shouldn't and none of the things it should. The first anomaly is the measurable increase in size. Across multiple radar sweeps and optical overlays, its dimensions appear to have expanded since the last round of public imagery. Not subtly, not within the margin of error, the shape has grown in a way no comet or asteroid ever has outside of science fiction. For a lifeless interstellar rock drifting through near-empty space, expansion isn't just unlikely, it's physically impossible. There is nothing out there to accrete. The interplanetary medium is practically a vacuum, with fewer atoms per cubic centimeter than the best laboratory vacuums on Earth. An object traveling at tens of kilometers per second cannot meaningfully gather mass. There is simply nothing to gather. Yet, something on the surface of 3I Atlas appears to be generating new structure, as if material is emerging from within, pushing outward, reshaping its own geometry. Which brings us to the second anomaly, surface reorganization. When you compare the new images with older captures, entire regions look different. Irregular ridges have been replaced with smoother, patterned sequences. Cavities have expanded, edges have sharpened instead of eroding, and the transitions between these regions are clean, too clean. Nature doesn't switch textures like flipping a switch. Natural change is messy, chaotic, progressive. This is structured. In some frames, you can trace the evolution of the surface almost like growth rings on a tree, except these rings are geometric. They spread outward in consistent spacing, as if following instructions. We've seen crystalline growth on icy bodies before, but nothing on this scale, nothing with this complexity, and certainly nothing that reorganizes an entire section of a rotating object. Then there's the rotational data. A natural object undergoing solar heating typically tumbles or slows irregularly. But 3I Atlas shows micro-adjustments in rotation that look almost intentional, subtle corrections that counter disruptions rather than amplify them. Something is stabilizing it, or repositioning it, or preparing it. And perhaps the most disturbing observation, certain regions of the surface appear to be reacting to solar exposure in ways that defy natural models. Instead of eroding or sublimating as the object swings away from the sun, some areas brighten, harden, and take on reflective qualities, almost like surfaces being refined or reinforced rather than worn down. It's as though the object isn't resisting the forces acting on it, it's adapting to them. All of these changes converge to a single, unavoidable truth. 3I Atlas isn't behaving like a comet, asteroid, or any known interstellar remnant. It's behaving like something with internal processes, something capable of restructuring itself, something that may not be passive at all, because natural objects don't grow. They don't refine themselves. They don't reorganize their own surfaces in days. But something else does. Systems, machines, mechanisms, structures built for a purpose. And if 3I Atlas is undergoing transformation, then we must ask the next question, the one no scientific model is prepared to answer. What is it transforming into? What appears next in the new imagery is the piece that has shaken even the most conservative researchers, the kind of scientists who'd rather swallow glass than entertain anything speculative. Because once you zoom into the enhanced frames, the surface of 3I Atlas stops looking like geology and starts looking like design. The first thing that stands out is the explosion of geometric patterns across the surface. Earlier images hinted at hexagonal patches, but the new footage reveals something far more extensive and organized. These patterns have spread dramatically, covering regions that were previously irregular and chaotic. And while natural crystalline formations do create repeating shapes, they do not generate the kind of mathematically aligned, region-specific variations we're seeing here. Each hexagonal cell appears to follow an overarching framework, yet no two sections are exactly the same. Some have raised central ridges, others have recessed cores, some contain internal subpatterns, forming smaller nested geometries inside larger ones. This isn't the blind repetition of chemistry. This is structural diversity, like modules optimized for different functions, but built on the same base template. You don't see that in geology, you see that in infrastructure. Equally disturbing are the circular apertures distributed across the pattern regions. The earlier footage revealed 7. The new data shows far more, and their placement is anything but random. Some apertures sit precisely at the vertices where 3 hexagons meet. Others rest dead center in individual cells. Their distribution aligns with geometric ratios too exact to be accidental. A planetary geologist from MIT ran probability analyses on the spacing. Her conclusion, the likelihood of this arrangement forming through random natural processes is approaching statistical impossibility, and that's not a phrase she uses lightly. But the apertures are just the beginning. Radar returns from beneath the surface show that many of these openings connect to straight, consistent, right-angled internal passages, not cracks. Not fissures, passages. Some run horizontally, some vertically, and some intersect in perfectly aligned grids. Nature doesn't build hallways. It doesn't create corridors that maintain uniform width over hundreds of meters. It doesn't carve right angles in vacuum-exposed rock thousands of degrees below freezing. Architecture does. And then there's a feature that stops several researchers cold. In multiple regions, you can see faint indications of layered substructures, almost like support beams or reinforcement lattices beneath the surface. The reflectivity in these areas isn't consistent with minerals or ice. It behaves more like alloys, smooth, coherent, and sharply reflective in certain wavelengths. Even more alarming, some of these structures weren't there in older images. They have appeared, expanded, or refined themselves over mere weeks. That's not erosion, that's construction. And construction implies activity. At this point, the comparison with natural formations collapses. We're not looking at fractures, vents, or impact scars. We're looking at organized surface development, grid-aligned apertures, repeating yet varied geometric cells, subsurface corridors, material refinement. There is no category in planetary science for what we are seeing. And that's the problem. Because if this isn't geology, if these aren't the fingerprints of natural forces, then we're left with a possibility that no one wanted to put on the table but can no longer avoid. Someone or something is shaping the surface of 3I Atlas. Which leads to the next question, one that the new data forces us to confront. If these are structures, if this is infrastructure, what is powering it? The deeper the analysis goes, the harder it becomes to cling to natural explanations. And nothing pushes that boundary further than the combination of heat signatures, localized atmospheric pockets, and moving structural elements captured in the latest footage. These are not qualities of a dormant, drifting object. They are signatures of activity sustained, rhythmic, and disturbingly organized. Let's start with the thermal data. After perihelion, an object moving away from the sun should cool predictably. It's one of the simplest, most reliable behaviors in astrophysics. But 3I Atlas refuses to follow the curve. Instead of cooling, several regions maintain a constant temperature and others rise in pulsing intervals, brightening and dimming in cycles ranging from minutes to hours. These pulses are smooth, controlled, and repeatable across multiple wavelengths. They look less like natural outgassing and more like internal systems cycling through phases. Even stranger, when you overlay the thermal hotspots with the geometric regions described earlier, the alignment is nearly perfect. Heat isn't appearing randomly, it's emerging precisely where the hexagonal patterns intensify and where the circular apertures cluster. These hotspots behave as if they're the engines or nodes of some internal network. Then we have the localized gas signatures. Multiple instruments are detecting oxygen, nitrogen, and water vapor near certain surface regions, concentrations that should dissipate within minutes in the vacuum of space. Yet these pockets persist, clinging to specific areas, as if being replenished or contained, and the composition doesn't match typical cometary volatiles. It resembles the atmospheric chemistry you'd expect around a planet with active cycles, not an interstellar rock. No sublimation model, no radiolysis process, no collision-based explanation accounts for pockets of gas that stay pinned to repeating geometric structures, unless something is producing them, or using them. And that brings us to the feature that has left even the most skeptical researchers unnerved, the moving structure. One protruding cylindrical formation, previously dismissed as an oddly shaped ridge, is now seen rotating independently of the main body. In earlier footage, it appeared static. In the latest frames, it turns with measurable acceleration, a slow, deliberate spin that cannot be explained by natural torque, tidal forces, or rotational inertia. If the object itself were tumbling, everything would move together. But the main body remains stable while this protrusion rotates on its own axis, as if mounted on a mechanical bearing. And the rotation is speeding up. Across 8 days of observations, the rotational period decreases steadily, as though energy is being channeled inward. No comet does this. No asteroid does this. Nothing naturally occurring in deep space rotates independently while attached to a larger mass unless driven by a mechanism. When you combine all of this, the pulsing heat, the persistent gas, the accelerating rotation, you no longer have a geological puzzle. You have a system displaying purpose, behavior, coordination. It's not static. It's not decaying. It's not drifting. It's doing something. And the more we track it, the clearer one conclusion becomes. 3I Atlas is not simply responding to its environment, it's operating within it. Which leads us to a question no one wanted on the table this early. If these systems are active, if these structures are animated, what intelligence or what physics is driving them? This is the part where every scientific instinct screams for caution. Because once you assemble everything we've discussed so far, the geometric expansion, the interior passages, the pulsing heat, the persistent gases, the rotating structure, you inevitably crash into a question no one wants to confront. Is 3I Atlas a natural object obeying physics we don't yet understand, or is it something built? Inside research groups, this debate has become unavoidable, not sensational, not emotional, just a sober confrontation with evidence that refuses to fit inside familiar models. On one side, you have the technology hypothesis, the idea that we might be observing artificial behavior. Its supporters point to the same patterns we've seen in the footage: organized geometry, repeating structures, aligned apertures, interior corridors, symmetry across independent wavelengths. These are qualities that, on Earth, emerge only from systems designed with purpose. Even more compelling is the rate of change. Natural processes don't reorganize a surface in weeks. They certainly don't grow reflective alloys, vent controlled gas pockets, or rotate independent components. But engineered systems do, machines do, autonomous probes do. And the truth is, if these exact signatures were found in archaeological ruins, biological networks, or mechanical devices on Earth, no one would hesitate to call them artificial. The only thing holding scientists back now is the scale of the implication, admitting that something inside our solar system might be active and non-human. But the counterarguments are real and they matter. The skeptics warn that invoking technology too early is a trap. Humanity has 0 confirmed examples of alien engineering to compare against. All our interpretations are filtered through human design philosophy. Maybe nature can build complexity we've never imagined. Maybe some exotic interstellar chemistry is capable of self-organizing into patterns that mimic intentional structure. Maybe the heat pulses are the product of phase transitions we haven't studied. Maybe the rotation is caused by asymmetric outgassing we don't fully understand. And there is historical precedent for scientific misinterpretation. We once mistook pulsars for intelligent signals. We misread patterns in Martian terrain as canals. We filled gaps with the supernatural, the mythic, the extraordinary, only to discover mundane explanations later. Skeptics also argue that assuming intelligence introduces its own bias. If we lean too far in that direction, we begin connecting dots that aren't truly connected. Our pattern-seeking brains might be weaving meaning into noise. After all, humans are wired to detect design, even where none exists. But here's the problem. The counter-arguments, while logically important, don't actually explain the data. They simply remind us not to jump too quickly to conclusions. They don't account for synchronized geometric propagation, heat cycle regularity, structural rotation, and gas pockets that replenish themselves. They don't explain material that appears metallic in regions where none existed weeks earlier. They don't explain interior corridors with right angles. They just urge caution. And that's fine, caution is necessary. But there comes a point where extreme natural physics begins to sound less like science and more like denial. Because if nature produced this, then nature is operating on principles fundamentally beyond our current understanding, which would be extraordinary in its own right, perhaps even more unsettling than the technology hypothesis. So the scientific community sits in a stalemate. One side seeing machinery, the other seeing unfamiliar physics, neither able to fully rule the other out. But the footage doesn't care what we think, it just keeps evolving. And as it does, one question grows heavier, more urgent, and inescapable. If 3I Atlas is acting with purpose, what is that purpose? This is the moment where the discussion stops being academic and turns into something far more urgent. Because if 3I Atlas is changing, if its structures are active, its geometry deliberate, its internal systems engaged, then humanity faces a decision with consequences we can barely comprehend. What we do next matters, and doing the wrong thing could be catastrophic. Inside scientific and strategic circles, 3 main paths are being debated, each with its own risks. The first is the most straightforward: send a mission. Launch a probe capable of close-range imaging, spectroscopic sampling, and maybe even surface interaction. With modern ion propulsion, a fast intercept is theoretically possible within 18 months. This would provide the data we desperately need, the kind that settles the debate forever. But it comes with an obvious danger. If 3I Atlas is controlled, intelligent, or running automated protocols, a human-made probe approaching too closely could be interpreted as aggression. A probe might trigger a response we're not prepared to handle. The second path is more cautious: observe and attempt communication. Continue tracking the object with every instrument available, building an uninterrupted record of its evolution. At the same time, send controlled transmissions, mathematical sequences, narrowband pulses, symbols universal enough to signal intent without revealing too much. The theory is simple: if something is listening, it may respond, and if it doesn't, we lose nothing. But even here, the stakes are enormous. What does humanity say in its first message? Who speaks for the entire planet? Every bit of information we transmit could reveal strength or vulnerability. The third approach is the one scientists fear the most: prepare for defense. Some argue that any unknown active object approaching the inner solar system should be treated as a potential threat. They advocate developing kinetic interceptors, orbital platforms, and contingency plans designed to disable or deflect 3I Atlas if its trajectory changes toward Earth. But this poses its own nightmare scenario, because signaling hostility towards something vastly more advanced could provoke the very danger we're trying to avoid. If this object is peaceful, defensive posturing could turn peace into conflict. If it's not peaceful, our defenses may be meaningless anyway. History on Earth offers a grim parallel. Whenever civilizations with enormous technological gaps meet, the outcome tends to favor the more advanced side regardless of intentions. Even peaceful contact has reshaped entire cultures, often violently and without warning. Humanity may now be the less advanced civilization, staring at something that operates beyond our understanding, and that alone makes us vulnerable. So what do? The emerging consensus among the most level-headed experts is a blended one. Observe intensely, communicate carefully, prepare quietly. 3 strategies, running in parallel, minimizing risk without surrendering initiative. Watch the object constantly. Attempt non-provocative dialogue. Build contingency plans that stay hidden unless needed. Hope for the best but refuse to be blind to the worst. Because whether natural or artificial, benign or dangerous, one thing is undeniable. 3 Atlas is active. It is changing. And whatever it's preparing for, it's doing so at a pace that suggests intention. This is no longer a distant curiosity drifting through empty space. It is now a participant in our solar system, and we are part of its environment. The next move may not be ours to choose. But how we prepare for it, how we interpret these signs, how we respond could shape not just the coming months, but the trajectory of our civilization. The question is no longer, what is 3I Atlas? The question is, what happens when it finally reveals why it's here?